Alright, so this is basically a final review for the Algebra 1. It's little videos I'm making just to help you guys out, so if your teacher's not there, you can watch these and still get basically the same that a teacher can give you. So what we're going to do is this is going to be on solving a system of equations using substitution. So the first one we're going to do is, we'll start off with an easy one. And we have y equals 3x as our first equation. And our second equation is going to be x plus 2y is equal to a negative 21. So the whole idea of substitution is that in both of these equations, the y's are equal and the x's are equal. So since we know that y is equal to a 3x, we want to substitute this whole 3x quantity down into the second equation for y. That way, we have an equation of only x's. Once we do that, it's going to be x plus 2. Since it was 2 times y, and we're replacing a y with a 3x, it becomes 2 times 3x equals a negative 21. Now that we need to simplify this, we can distribute the 2, multiply, so we get x plus 6x equals a negative 21. And then we combine like terms. 1x plus 6x is 7x equals a negative 21. Now, the way we can get rid of this 7, since the 7 and x are being multiplied, the inverse of that is division. Divide both sides by a 7. And x is equal to negative 3. So it's pretty easy. But the only trick here, it's not really a trick, but we actually only found x. In order to find the solution to this system, we need to find both of our variables. Since we found x, we also need to find a y. The nice thing here, though, we know that y is equal to 3x. We also know that x is equal to a negative 3. So we can just take this and again substitute like we did in the beginning, negative 3 in for x. And we get y is equal to 3 times a negative 3. Y is equal to a negative, ooh, it's an ugly looking 9. Negative 9. So our solution set is going to be negative 3 comma negative 9. And that's our answer. If we wanted to check our answer, we could substitute a negative 3 in for x, substitute a negative 9 in for y. We could simplify it and it would equal negative 21. Likewise, we could put a negative 3 in for x, negative 9 in for y, and again it would equal to. I'm not going to do that for time's sake purposes, but it is something you can do to solve it. So, on a little harder one for substitution, we are going to look at x plus 5y is equal to negative 3, and then also 3x minus a 2y, 2y is equal to 8. Now if you notice, the difference between this problem and the problem prior is that in the problem prior, y was already solved for. Okay? In our problem, neither variable is solved for. So the one thing we can do, and it makes it very easy for the top equation, is we want to get x or y by themselves. If you notice x has a coefficient of 1, it saves us a lot of work. So really, if we can get x to become by itself on the left side, we can just do substitution. So what I'm going to do is subtract a 5y from the left and the right. So, actually let me erase this. And we're going to subtract 5y, subtract 5y, and we're left with x equals negative 3 minus a 5y. If you notice, I didn't combine the negative 3 and the negative 5y since they both do not share a variable. So we can't combine them in not like terms, but you guys already knew that. And then here's our original equation, which I erased to begin with. We're going to have a 3x minus 2y equals 8. Now the nice thing is, like we said in the last example, in both these equations, x's are equal, y's are equal. Since we know that x is equal to a negative 3 minus 5y, we can substitute this whole quantity into the second equation, and we'll be left with one variable, which is exactly what we want, so it'll be nice. So when I rewrite it, we're going to get 3 times the quantity negative 3 minus a 5y minus a 2y equals 8. Okay? So then when we distribute the 3, again distributing multiplication, we're going to get a negative 9 minus 15y minus 2y is equal to 8. Combine like terms, we are going to get negative 9 minus 17y equals 8. Now, in order to get rid of this minus 9, we need to add it. I'm running out of room. That'll cancel, and you're going to get negative 17y is equal to 17. Now, divide by negative 17. This is where it gets fun and tedious. And y is equal to a negative 1. Okay. So now we have a y. Just like in our other examples, we must also find x. The nice thing here is that we know that x is equal to a negative 3 minus 5y, and y is equal to a negative 1. So we can just distribute or substitute the negative 1 in for this y. So we have x is equal to negative 3 minus 5 times a negative 1. X is equal to negative 3 plus 5. X is equal to a positive 2. Now x is 2, y is negative 1. Our solution set is 2 comma negative 1. Again, just like the last problem, we can plug a 2 and a negative 1 in for x and y, simplify, and your equation will be equal, since 2 comma negative 1 is our solution. And these are the two practice problems I'm going to give you for substituting to solve a system of equations. All right, thanks.